Good afternoon, everyone. I'm Cheryl from SLNG. And today we have two challenge statements from SLNG. The first would be the recovery and utilization of vessel return gas, which will be shared by myself, followed by power generation via discharged seawater, which I will hand over to my colleague Desmond to share subsequently. So before we move on to the challenge statements, let me give you a very quick overview of SLNG as a company. Okay, so SLNG, we are the owner, developer, and operator of Singapore's and Asia's first open access multi-user LNG terminal. We are located on a 40 hectares plot on the tip of Jurong Island. Our LNG terminal actually supplies about 25 to 30% of Singapore's total natural gas demand for power generation. And therefore, we are a critical infrastructure that contributes to energy security by ensuring uninterrupted gas send out. If you look at the right, a very quick history of the development of SLNG. We began commercial operations in 2013 with 2 LNG tanks and a primary berth with a send-out capacity of 3.5 million tons per annum. By 2014, we had completed our secondary berth and third tank. And if you fast forward to today, we actually have 4 tanks as well as a send-out capacity of 11 million tons per annum. So for SLNG, beyond actually operating the terminal and meeting our energy security mandate, we are actually stepping up to become a catalyst for a vibrant LNG ecosystem so as to support Singapore's ambitions to be an LNG hub for the region. So part of this vision actually entails harnessing sustainability to facilitate energy security and to catalyze new possibilities in this energy transition. So we have the long-term ambition to be net zero carbon in our operations, which will allow us to be an integral part of the carbon neutral LNG supply chain. So we have been stepping up our efforts to develop a carbon roadmap, which comprises of carbon reduction, offset, as well as green renewables initiatives. So the 2 challenge statements that we are sharing today is actually meant to bring us closer to this objective of reducing our emissions and achieving our long-term ambition. So the first, as mentioned, is the reduction of flaring via recovery of vessel return gas. And the second is green power generation. So for the first challenge statement, which is, For the first challenge statement, which is the recovery and utilization of vessel return gas, to provide some context and background, part of the services that we offer include gas up, cool down services, where we supply LNG for LNG carriers that need to have their cargo tanks cooled from ambient to cryogenic temperatures before loading of their next LNG cargo. So if you look at the process diagram at the top of the slide, we have about 40 to 60 gas up, cool down operations a year, and each operation is about 24 to 36 hours. During the gas up, cool down operations, return gas from the vessel actually goes back to our terminal with a fluctuating return gas flow rate of 5 to 30 tons per hour during operation. This vessel return gas can be sent either to our BOG, our boil off gas system, or they are sent directly to the flare. So in order to be accepted in our terminal's boil off gas BOG system, the gas has to meet very stringent criteria, which is a C1 composition of greater than 80%, nitrogen less than 5%, CO2 less than 0.1%, and temperature less than negative 30 degrees Celsius. So currently about 44% of the vessel vapor return actually meets this stringent criteria and can be accepted back to our terminal BOG system. However, the remaining 56% of vessel vapor return is actually currently sent to flare as they do not meet this stringent criteria. And actually the limiting factor is the CO2 criteria of less than 0.1% because of the cryogenic system. So this brings us to our challenge statement. We have done a high-level estimation, and out of the 56% of vessel vapor return that's sent to flare, actually as much as 71% has suitable composition for potential reutilization, with C1 greater than 80%, nitrogen less than 5%, and CO2 less than 5%. As such, we are looking to call for innovative proposals, such as innovative engineering system designs that can connect and direct the flare gas with users such as power plants, gas turbines, and boilers on Jurong Island, or innovative systems such as fuel cells that can consume this flare gas. By doing so, this can help to reduce our CO2 emissions from flaring. Furthermore, we expect our volume of GU gas up, cool down operations to increase, and by actually being able to recover the vessel return gas, we can potentially reduce up to 4,200 tons of C1 emissions per annum by 2035. So in terms of the proposal considerations and outcomes, the proposal should elaborate the relevant research or engineering design activities and plan. The outcome should be a solution of demonstrable design maturity for implementation consideration. The solution should address the measurement, gas analysis, operability, and flare gas return and logic control integration, both from the vessel return side as well as the flare gas and user side. We are open to consider proposals which involves a piloting phase followed by a full-scale implementation solution. Participants also have the option, if they wish, to submit their proposals together with an identified potential flare gas end user. Or alternatively, participants can choose to submit their proposals of just the design solution and subsequently work with SLNG or the Innovation Challenge Committee to engage a suitable flare gas end user.